Imagine standing near a colossal glacier as a massive chunk of ice, perhaps the size of a small skyscraper, breaks off and plunges into the ocean. What kind of powerful natural event does this dramatic displacement of water trigger? While spectacular and forceful, typical iceberg calving events do not generate true tsunamis in the same way an underwater earthquake does. They create significant localized waves, but these are fundamentally different from the destructive, ocean-spanning tsunamis that can devastate distant coastlines. A true tsunami is almost always caused by a rapid and massive displacement of the entire water column, from the seabed to the surface. This usually occurs during a powerful underwater earthquake, a significant submarine landslide, or a large volcanic eruption. These seismic or geological events transfer immense energy into the ocean, creating waves with extremely long wavelengths that can travel across vast ocean basins with minimal energy loss. Iceberg calving, even from very large glaciers, displaces water primarily at the surface and over a much smaller area, generating what are often referred to as splash waves or local impulse waves. To understand the distinction, consider the scale of water involvement. A calving event creates powerful waves, sometimes tens of meters high at the source, but these waves propagate locally within fjords, bays, or restricted coastal waters. Their energy dissipates rapidly over short distances, typically within a few kilometers or tens of kilometers from where the iceberg falls. These localized waves can certainly be hazardous to ships or structures nearby, but they lack the massive wavelength and deep-water energy transfer mechanisms required to travel transoceanically like a true tsunami. Scientists occasionally use terms like iceberg tsunami or splash tsunami to describe these very large localized waves produced by calving events. This acknowledges their immediate destructive potential within a confined area. However, it is vital to differentiate them from seismic tsunamis, which are generated by geological forces disturbing the entire water column and can travel thousands of kilometers. The crucial difference lies in the source mechanism and the wave's ability to maintain energy and destructive power over enormous distances. So, while the sight and sound of a calving glacier are truly awe-inspiring, producing impressive waves, remember that these are powerful local events, not global threats. Understanding this fundamental distinction helps us accurately appreciate the true mechanisms behind these natural phenomena and interpret their potential impact.